Again? Yes.
ପିଲା ଖାଇଛ ଆମେ ଆଳୁ କର କ'ଣ ଟପିକ୍ଟା କ'ଣ
ରିଲେସନ୍ ଉପରେ ଦେଖେଇଛି ପିଲାଙ୍କ ପାଇଁ ଦରକାର ସେଇଭଳିଆ ଯେଉଁ ଜିନିଷ କହିଥିଲେ ସେସବୁ ଟିକେ ଆରମ୍ଭ କରିକି
ଆସୁଛନ୍ତି ତ
ଆସୁଛନ୍ତି ଖାଇ
ଆସୁଛନ୍ତି ତ
ଆସୁଛନ୍ତି ଖାଇ ଆରମ୍ଭ
ତାକୁ ଡାକିଦେବେ
ଆସୁଛନ୍ତି
ଯିଏ ଖାଇସାରିଲି ପଳେଇ ଆସିଲେ ଡାକିଦିଅ ତମ ପାଇଁ ପିଲାଙ୍କ ପାଇଁ
Good afternoon to everyone. Welcome back after boss lawn. Now I like to request Professor Roman and Mr. Susandaja and invited talk by Professor Keith. Kindly enter the session. Good afternoon. I would like to invite you Professor P.K. Rai from Berhampur University, and he will deliver his presentation within 40 minutes.
Very good afternoon to everyone. I would like to thank the organizer, Jena, and other esteemed members. I would like to give me opportunity. Something about my research here. So, as this is the name is pure and applied mathematics, I am basically a pure mathematics researcher, and a researcher in number theory. So, my topic of presentation is multiplicative relations of mathematics. Hello. So before I start, I would like to tell you recurrent sequences, some basic ideas of recurrent sequences. Then I will go for the multiplicative relations. Then that is a research work. If I get time, then I will definitely tell you actually we are doing. So my main focus is to take actually what are research going on this field in recurrent sequences, so that you can motivate and you can do the research on that particular field, recurrent sequences. So you know that everybody know what is a recurrent sequences. A sequence, you say, and this is AM sequence here. This sequence AM, if it's nth star, expressed in terms of previous terms, then it is a recurrent sequence. That we know. Recurrent sequences either it is homogeneous or it is non-homogeneous, right? So I will show you. You see, this is the general form of the recurrent sequences here. It is a linear recurrent sequences. An is equal to this, where Fn terms depend on this, whether it is an homogeneous one or a non-homogeneous one, depend on Fn. If Fn is 0, it is a homogeneous. Not equal to 0, it is a non-homogeneous recurrent sequences. So, one example is, what is the order? Order is n minus k, n minus n minus k. That is the smallest number of preceding terms equal to determining the next term is called the order of the recurrent sequence. So that you know, this is the kth order recurrence sequence. So if I say, one example is, simple example, this is Fibonacci sequence. This is Fn minus 1 plus Fn minus 2. It is a very simple and this is second order homogeneous recurrent sequences. Correct? Similarly, many second order recurrent sequences are there. So another one very closely associated is Ln, which is Ln minus 1 plus Ln minus 2. But any recurrent sequences must have some initial values here. So here the initial terms are f1 is equal to 1, f2 is equal to 1, wherein Lucas sequence is L1 is equal to 2 and 3 and N2 is equal to 1. Okay. So sometimes some people are taking L0 as 0 here, L0 as 2. Correct? So this is the Fibonacci and Lucas sequence, and many properties are there between these two references. These are homogeneous. Some non-homogeneous also recurrent sequences are there. That is the Leonardo sequence. That sequence is nowadays the people are doing research on that particular Leonardo sequences. So I will not go on that. So many second order and these are some examples of third order recurrent sequences here. When k is equal to 3, this is called the Padovan sequence, Perrin sequence. So this is the general form that I have already told you. This is a homogeneous recurrent sequences. Now, you see, any recurrent sequences has a closed form, okay, and that is called the binary form. By the name of binary, so it is called the binary form or closed form of the sequence. So if I say this is a recurrent sequence and you know how to solve that recurrent sequence, you know homogeneous recurrent sequence solutions part. That is find the auxiliary equation there. So if I take the auxiliary equation, that gives alpha square is equal to alpha plus 1, and if you solve it, you have the values of alpha is minus 1 plus root 5 divided by 12. That's the golden number that we know. Okay. So this is then there is a closed form. This is called Fn, which is equal to, you can say, if alpha beta are two roots here, alpha is 1 plus root 5 by 2 and beta is actually 1 minus root 5 by 2, then this is the closed form where alpha to the power n minus beta to the power n divided by alpha minus beta. Okay, so this is the closed form. So there are binary formula for other recurrent sequences also. So there is a task how to find the binary formula there. So we can apply generating functions method. Different methods are there in order to find this binary formula. So I will not go for that. So this is the closed form of the Fibonacci sequence. Similarly, the closed form of the Lucas sequence is alpha to the power n plus beta to the power n. The same alpha and beta here. So other recurrent sequences are there. One is called balancing sequence, and another is called Lucas balancing sequence. So this is 6bn minus 1 minus bn minus 2, and this is 6cn minus 1 minus cn minus 2 with different NCL here. Here b1 is equal to 6, b2 is equal to 35, c1 is equal to 1, and c2 is equal to 17. So different binary recurrent sequences are there, ternary recurrent sequences are there. So let us see, this is the closed form of this one. So I have written there some closed form of this one. You see, this is the characteristic equation. Alpha is equal to 1 plus beta, Fn is alpha to the power n minus beta to the power n, and the value of alpha minus beta is equal to root 5. Yeah. That's why it is written root 5. Similarly, for Lucas sequence, this is the binary formula. And this is the binary formula for Padovan sequence actually. Okay, this how to find this? There is a tax there. Okay, so this is the root here for k is equal to 0. Solving that equation, we get this one. It's not very easy to find it because it is a cubic equation. If we solve it, the values are like this. Alpha, beta, gamma are the roots of the characteristic polynomial obtained by substituting k is equal to 0, 1 and 2. Similarly, the binary formula for pairing sequence is this much: alpha to the power n plus beta to the power n plus gamma to the power n, where alpha, beta, gamma are this. Okay. Now, my focus is to give you what kind of research are going on this type of sequence actually. So there is different kind of researchers are there in number 2. So they are finding, they are searching for some Fermat's number and some they are showing some perfect, they are showing that what type of perfect square also, whether the sequence is having a perfect squares or not. So that type of research are doing that, but I will give only focus on this very interesting topic that is called Diophantine M tuples. So I will tell a little bit about that Diophantine M tuple here. So what is the Diophantine M tuple here? Diophantine M tuple. So you see, I will give some ideas about this Diophantine. The Greek mathematician Diophantine of Alexandria first studied the problem for finding these four numbers. This is 1 by 16, 33 by 16, 17 by 4, and 105 by 16. So this is he is the first person to study the problem of finding four numbers such that the product of any two increased by 1 is a perfect square. Okay. So these are all rational numbers. So these are four rational numbers, but Fermat found the first four integer satisfy the same property, that the product of any two increased by 1 is a perfect square. So this is the first set here: 1, 3, 8, and 120. This is the Fermat. So you see the product of any two plus 1, that is 1 into 3 plus 1 is a perfect square. Any two is a perfect square. Okay. Now Euler generalized it, and we found an infinite family of sets like this: A, B, A plus B plus 2, then 4 R times R plus A into R plus B into R plus B, where this R is AB plus 1, where AB plus 1 equal to actually R square. So this is found by Euler. This was the Fermat. This one by Greek mathematician Alexandria. So that is Diophantine of Alexandria. So this is A plus B plus 2, and 4R into R plus A into R plus B. So these are the four tuple here. So this is M is 4 here. Okay, it is a 4 tuple. Similarly, now you see another Euler also added another fraction here to find out the full tuple. This is a full tuple. then quintuple. So that result is 777 divided by 480. 777 divided by 480. So now the question arises that actually diaphantine is tuples that can be extended to any number or not. Okay, that is the question now. So this is found by earlier that in rational one it may be possible. Okay, but in case of integer there is no quintuple. So it is a conjecture. That conjecture is that does not exist diaphantine quintuple. Up to 4 tuple exists, but there does not exist a diaphantine quintuple. That has been proved recently in 2019 by a professor from Purdue University, one of my co-author also, that is Alan Tombe. He has proved this conjecture, and in 2009 it was proved. Okay, so that is there is no, that does not exist a diaphantine quintuple. Okay, but this one for rational one, it may be possible, may not be possible. That is, there is, we cannot say that does not exist. There is no conjecture here. Okay, for rational case. But for integer case, there is a conjecture, and that has been already proved also. That there is no, there does not exist any quintuple. So the definition says that a set of n positive integers, say a1, a2 up to an, this m positive integer is said to be a diaphantine m tuple if ai is a, this is the definition I have already told you. Ai is a plus 1 is a perfect square where I is less than j and I and j lies between 1 to n. Okay. So this is called the for integer case. This is simply, we say it is a diaphantine m tuple here. But we say it is a diaphantine, rational diaphantine m tuple if it has m number of rational numbers, that is a1 equal to m, and satisfying the same property, that is ai is a plus 1 is a perfect square. Now, okay, comes to this how this is related to the Fibonacci sequence here. The pupils related these recurrent sequences with this diaphantine m tuple. So in place of this, you know what is an exponential diaphantine equation? Diaphantine equation you know, but what is an exponential diaphantine equation? Exponential diaphantine equation is what? So it is an equation where the bases are integer, correct? Known integer actually. The bases are known integer, but the exponents are unknown integers. They are integer, but they are unknown. Like this is 2 to the power a plus 3 to the power b plus 1 equal to 0. Suppose this is a diaphantine equation here, but this is an exponential diaphantine equation because a and b are unknown integers here, and in the base we will see that they are all known integers, right? So this is the meaning of exponential diaphantine equation. So exponential diaphantine equation also a great interest of number theorists in order to do the research work in that field. Okay, so how much time will we take this? 20? Only 10 minutes?
No.
Okay. Okay. So let's start with this. Next one is Philae's problem. Okay. S.S. Philae is a great mathematician, you know. After Ramanujan, many people say that he is the second man in the number theory. Not number theory, mathematics is a great man. Okay. There is a problem called Philae problem. That problem says like this. So find a positive integer n and m such that the exponential diaphantine equations a to the power n minus b to the power n is equal to f. When these a, b, f are given positive integer, A, B, and F are given positive division, and we will find the values of N and X. Solving that, we'll get the value of this is a Bill's problem actually. So, in case you see, okay. So let us start with the my topic. Yeah. So you see, what is the meaning of multiplicative dependent here? The non-zero complex number alpha 1, alpha 2 to alpha n are said to be multiplicative dependent if there exist integers like k1, k2, kn, not all zero, satisfying the product is equal to 1. Right? Otherwise, they are called the multiplicative independent. This is about the any complex number alpha 1 to alpha n. But a set M is said to be multiplicatively dependent if there exists non-zero element like this belongs to capital M, which are multiplicatively dependent. Multiplicatively dependent definition is there. Now, any vector in this field is said to be multiplicatively dependent if its coordinates form a multiplicatively dependent set. So, this is the meaning of multiplicatively dependence. Now, why the people are studying multiplicatively dependency? Because it is used in order to find the zero, in order to study the zero distribution and equivalency properties of different kind of zeta function. You know, there is a Billy zeta functions and the null zeta function also. Okay, so that's what people are studying this things here. Then how to find how to search the primitive roots here. Multiple dependency also help in order to search the primitive divisions in recurrent sequences. So recurrent sequences I have already told you. So in order to find or in order to search the primitive roots there, you know what is the primitive roots? Primitive roots means what? It is a prime number. Primitive root for a sequence A. It means that it is a prime number that divides the nth star, but that doesn't divide the previous stars there. Okay, that means that divides P is a prime here, P divides AM, but P doesn't divide AM where AM less than what? N. Okay, so previous stars, it doesn't divide the previous star, only divides the nth star there. Okay, so that's from the primitive divisors. Then there is a Chronicles primitive division theorem that has been proved in 1913. This is relating to the Fibonacci number here. So for n greater than equal to 13, time is over n. Time, sir? I have only 5 minutes. So chemical primitive division theorem for n greater than equal to 13, the nth Fibonacci number has at least one primitive divisor. So in that proof you can see in that paper. Solving these two equations here, exponential differential equation, that is f to the power x and f to the power y for some integer x and y, and they have proved that the maximum n is less than equal to 1. So how to find the bounds of that actually? In order to find the bounds, they are actually using different methods here. There are different methods in order to find the bounds there. One is called linear forms logarithms. Linear form in logarithms. Okay, you can find many books for linear form in logarithms. And another one is the matrix theorem is there. Becker-Davenport method is there. LLL algorithm is there. So many things are there in order to find the bounds there. Okay, so here the bound is maximum and n is less than equal to 12 here. So the 13 terms, any two Fibonacci number are multiplicative independent. So how this multiplicative independency also depending on this primitive divisor that I have already shown you here. Now come to our work. Okay, so these are some motivation actually. This is Luca and Jacob solved this equation. This is I have already told you UNI is what? UNI is the nth order of recurrent sequences. The product of 1 is equal to 1 is multiplicative independence. This is the definition. And this Luca and Jacob solved this one, keeping the exponent xi and k fixed. Later, Gomez and Luca solve this equation 1. Xi is a variable, where UNI are taken from different bilateral sequences. The previous one taken from the same bilateral sequences, but the second one is actually from different bilateral sequences. Now there are some motivations so that I will not tell you again. So we have considered this particular recurrent sequences under some conditions. The condition is given as C1 is greater than 1 plus C2 up to Cs, or this C1 is greater than equal to this, and with C1 is greater than equal to 4 also for both the conditions here. We have found the characteristic polynomial, then binary formula, then again we apply that method I have already told you, Becker level method, you have to find the bounds. So the bounds is like this. These are the bounds of this main theorem. This is the main theorem. So we have found this bound, and so the theorem 1 is this one. This is the theorem 1. Is a recurrent sequence of fixed orders and then equilibrium of the form is. This is another form, and this is just recently published in Journal of Number Theory. Thank you so much.
Thank you.
Thank you very much. So, any question?
For students only, do you know what is an happy number? Anybody? What is an happy number and sad number?
Until only one or not zero.
So now I go
1 0.
happy number definition is there.
1 0.
Yeah, no.
1.
Yeah,
Happy is 1, unhappy 0.
no. Anybody you know? You see, if you consider any integer here, any integer you take, okay, then the process is like this. Just square the digit of that integer and solve it, okay, and continue that process. If you are getting 1, then it is an happy one. Okay, if you are not getting 1, then it is an unhappy one. Okay, for example, suppose we start with 13. 1 3 is a positive integer, whether it is an happy number or not. So we'll start with that process. We'll write 1 3 as 1 square plus 3 square. Gives us what? 10. Then we again start with 1 square plus 0 square. Gives us what? 1. So it is an happy number. Okay. But if you start with 4, just start 4 square is what? How much? 16. 1 square plus 6 square is how much? 37. 3 square plus 7 square is how much? Calculator is
58.
58. 5 square plus 8 square is how much?
99.
5 square plus 8 square, 64 plus 89. 8 square plus 9 square is how much? 64 plus 91. 81. Okay?
145.
145. 1 square plus 4 square plus 5 square. Sorry, yes, sir. Sorry, yes, sir. How much?
52.
42. 4 square plus 2 square.
16.
20. 2 square plus 0 square.
4. Again 4.
Again that comes to 4. So we are not getting 1. We get a circle there. So I will show you that figure if I get some other.
Yes, sir.
Thank you, sir. Yeah, today is 30. This is the happy day. Any questions? No questions.
will be delivered by Professor S.K. Tripathi, IIT Suran. I would like to request Professor Bill to chair the session. Please, sir.
Thank you. So the next speaker is Professor S.K. Tripathi from IIT Suran.
Sir. Mic on.
Very good afternoon to everybody, and I am very much thankful to the organizers for inviting me to deliver the research output that I have been involved in the last some of the years before the young minds. If at all a part of it can enter into the young minds and they can recover the challenges that we will be having in this particular problem, and they can solve it, and I will be very happy. Okay? Basically, I am a mathematician, I am a physicist. So mostly I will talk about the physics and less of mathematics. Even though we cannot divide ourselves of the mathematics, still I will try not to speak a lot of mathematics. Rather, I will try to do the things that I already said. So let us now move to a world of dream and imagination. Suppose we are given a chance that suppose we are lazy. Let's not think of that we are very much lazy. And we don't wish to work very hard. Then, but we are talented. But we have that kind of intelligence to work that within short time. So we can obviously find for some surplus. So that's why it gets usually recruit lazy people but intelligent for the development of Microsoft. Anyway, so it's not think of this shortcut. As I have already mentioned it, that whether we can have a shortcut in traversing through different parts of the same universe. So whether we are very wish to travel from one part of the universe to the other, but with a short time and short distance, can it be possible? Even if I have suppose two universes, let's not think of two universes, and suppose I wish to travel from one universe to the other with a less time and less path travel. Whether it is possible or not, I will give you that. So the interesting tunnel which can realize this dream is known as the world. So it will connect the two different spacetimes. Already Professor Misra has given a part of it. Suppose what is space-time? Suppose we think of a piece of space. We think of a piece of space, suppose. Suppose I think of a piece of space and I integrate this space with time.
I integrate this space with time somewhere, maybe mathematically, maybe imagination with some sort of imagination, I integrate it in somewhere or other. So I will get a fabric of this space time. It is a kind of cloth, just like a piece of cloth that we are having. So it is a kind of cloth, space-time fabric. And if I put a kind of mass upon it, suppose I put a mass, particularly if I put a piece of mass upon this, obviously I will get a kind of curvature around this. Clear? And this curvature will obviously go on increasing if this curvature will go on increasing if I increase the amount of mass. And certainly at some point of time I will get a curvature like this, where no more this space-time can withstand the mass of that object. And focus upon this. Similar situation is there in that particular figure that I have just explained. Okay, you think of that kind of situation. Let me call it black hole. Let me call it. Suppose anyway, whatever term that you can give it, let us not call it a black hole. And you think of a similar one. You now think of a similar one from the other side. Okay. Now you have a tunnel connecting two black holes. One will be called as black hole, the other I will call it as white hole. Because I don't have any access to this part, so I call it a white hole. And the tunnel that is connecting these two parts, I call it the wormhole. And obviously, if this part of the universe is there and another part of the universe is there, if anybody can travel through this, if possible, if anybody can travel through this, then it will reduce your green travel time as well as distance. And this particular concept, this particular tunnel, we call wormhole, and also we call it the Einstein case. Whether it is possible or not, because already we know that black holes are available in nature. Black holes do exist in nature, but whether such a wormhole, such a dream travel path is possible or not, or whether we can construct such a path, so that will be discussed. Theoretically, it is very much possible. As I have already told you that you can imagine that one theoretically also it is possible. You can solve Einstein's equation. The equation that already Professor Misra and Professor Singh has already described before you. So we can solve those things for certain matrix and we can obtain theoretical solutions from formulas. But to our estimate, we have not yet seen any problem. Even though there have been many trials to look at wormholes in the universe, but till date, as far as my knowledge is concerned, it has not been observed. We don't have that kind of wormholes right now. Because of this fact, wormhole has so far been a subject of science fiction, and we can write anything, any kind of fiction about this. We can write many stories regarding the dream travel through this space-time and anything. Also, there is a particular movie that you can have, at least you can Google it, Interstellar movie, you can check it, where the famous Nobel laureate Keith Thorne has been involved, and you can go through that. So, it has remained a subject of interest in the sense of fun for a dream travel through a shortcut distance and time. But once the wormhole has been felt in your mind, immediate question arises whether it is possible to walk through that space-time, whether it is really possible, whether it is possible, whether we can construct such a thing. So two issues are there. Why we are not able to imagine something, immediately we imagine we cannot have that particular in reality. Two issues are there. One related to its small size, another its stability. That is more important, of course. issue size can be handled. Small size wormhole we don't have any problem. But its stability is an important aspect. As soon as the wormhole is small, it will collapse. Even if you set certain light particle, very small particle through it, the wormhole will simply roll off. It will collapse. It will come up. So it is not possible for anybody to enter into that wormhole. So that part is an important part. But how we can handle this? Issue related to size can be handled as Professor Misra described regarding the rate and cosmic acceleration. Also a part discussed by Professor Singh. But the issue related to stability, that is still to be worked on. So in order to think of that the wormhole to be stable, we need a particular kind of matter which should violate the particular energy condition. We call it the conservation of momentum kind of thing. We can see it is the conservation of momentum kind of thing. So that is to be violated. So if the wormhole can be traversable, we need a particular kind of material, particular kind of mass, which we call exerting mass. Exerting mass means it should be having negative energy density, negative mass. And negative mass, the existence of negative mass is not possible classically. Within the classical physics, classical domain, we cannot have that negative mass. So, within the classical domain of the classical physics, traversable wormholes should not exist. And when it should not exist classically, obviously we have to dream it, we have to think it as a part of science fiction. But hold your breath. It is possible that we can at least have some route to construct traversable wormholes. At least we can set our dream to move through it. So let us now listen. How it is possible? So this is the simple mathematical techniques behind the wormholes. I will not go into the details of this because time for me to possible is only short. So these are some of the basic conditions that one should at least have if you are constructing a traversable wormholes. I am not going to the details of it. The mathematical part simply I am avoiding. So how we can construct? Two possibilities. Two clear-cut possibilities are there. Very clear. The first thing that we can explore quantum mechanics. The second thing that you change the perception of gravity. The way that we have read gravity field so far, that should be changed. How? We will either modify it or you will consider it some other way. So one by one, at least I will give some glimpse of both the kind of consideration. So let us now explore the quantum mechanics. In quantum mechanics, at least we have one particular fundamental effect. It is known as the Casimir effect. Casimir effect is simply the attraction between two plates. When you take two charged plates, uncharged plates, placed close to each other, they will attract. And the attraction force generates a kind of energy density which is negative. And we require a negative energy density to construct a bubble. So this is the thing that we are looking for. So it is a pure quantum effect and simply within classical quantum it is not able to explain. So we obtain a kind of negative density in Casimir. So it will give us some kind of force that we can construct the traversable wormholes in the Lagrange condition with this Casimir negative energy density. Okay. Also, the second aspect that we can consider modification of gravity, geometrical modification theories, apathy theory already discussed. FRT activity, FRM also discussed. So we will consider three different theories here, where we have considered this Casimir energy density and try to construct theoretically the Casimir wormholes and raise certain hopes for traverse through a shortcut path journeying through different parts of the space. So this is the basic formalism for FRT theory. The action starts with the action. These are the field equations for FRT gravity for the wormhole. The step function that we are getting out of this for the FRT theory, the wormhole step function that we are getting is like this. So let us now come to the graphical part of this. So this is the wormhole step function within the similar energy density that we are having. So we considering a modified gravity theory like FRT published in 2021. So it satisfies all the conditions as it is stated. So these are the equation of states for the FRT gravity Casimir wormholes. These are the important findings of the Casimir wormholes. It is possible within FRT gravity to construct traversable wormholes. Another consideration that in quantum mechanics there is a concept of minimal length scale. You cannot have any amount of length of your hole. You cannot have any amount of length of your hole. There is a minimal concept. Below that, no length is possible. So you can measure a particular small length, and that concept is known as the minimal length concept of the order of Planck's order, and this modifies the uncertainty principle in physics. So the modified uncertainty principle is like this. If you incorporate this particular concept, if you incorporate into the construction of Casimir wormholes, you will get this kind of wormholes. The set function geometry or the geometry of the wormholes will be done like this. So you can say the set function will have now three different terms. The third term is particularly coming from the concept of minimal length. If you drop that J part, then obviously that part will be simply removed. The second part speaks of the modification of gravity. That is also published in 2021 with the different values of the parameter beta. Same thing. Now come to the executive gravity. Another modified gravity values. Okay, I think this. So field equations like this. Similar way of calculation, but different geometries, different concept, different gravity fields. So same calculation repeated, but with beautiful graphs. Simply you can check the results, similar results, but different because of the gravity fields. It is published in 2024, of course. Published in 2024. Recently it is published, the same one. Third, geometrically modified gravity theory, FRM theory. Same kind of calculation, but different theories, different concepts. Any questions you can have this? The energy conditions for this. Now we will see the geometry. You will see the geometry for this without any length, minimal length concept. You see this path. If you incorporate the minimal length concept, now you check that because of different constructions, you will see the dumbbell set here. So dumbbell bojale na do. This is the same thing that we are thinking of. We are playing with those dumbbells, the dumbbells that we are playing, and we are not trying to obtain the beautiful constructions of traversable wormholes. So for different construction, it is for different value of beta, and this is for beta equal to 1. Here, when you increase the value of beta, obviously the doctors are simply overlapping. And when you are taking lower and lower values of beta, you can find out that the dongle cell or CTV widely separated from each other. So these are all about, this is what is published, but in archive you can check it. So this is all about the construction of Casimir wormholes in three different theories. Now let us take some 1 or 2 minutes in the observational signatures. Even though wormholes are not yet seen, but there are observational signatures, and people are now trying what are the signatures that the wormhole should provide so that we can observe through different devices. So this is a publication in 2024 from a Chinese group that they have considered how the photons are playing just at the mouth of the wormholes. So these are the pictures. The last remark that I can say that this is a picture of black hole. Once black hole was considered as a solution to the Einstein field equation, but people thought that black holes are simply theoretical objects. There is no physical reality for black holes. But nowadays we have enough mechanism to know that black holes are really existing in nature, and we have taken the snapshots of this. Probably the groups they are involved in taking the snapshots of this black holes, maybe awarded Nobel Prize in some recent futures. In the same light, I can say, even though today's time that we do not have any mechanism, any mechanism or sufficient mathematical framework to understand wormhole and its observation, time may come that we may get traversable wormholes, and our dream travel through it can be really possible. So these are some of the opportunities that we have, and I invite all of you to poke your nose into it, extend your mind. You should look at this problem and find out how the wormholes can be constructed, the traversable wormholes can be constructed, and how it can be observed through different devices. Thank you. Thank you all.
Thank you, Professor Tripathi, for this new idea of this Kashmiri wormhole, this Kashmiri wormhole geometry. So, ऐसे तो मुझे डाउनलोड देखते थे। The last 4-5 years, we are actually collaborating with last 10 years for a different kind of research. Normally, I look after the geometry part. So we are trying that what shape of double should be there, and what should be the mathematical platform for that. So if you can get a proper geometry to make this double, then one day or other the cobra will certainly come. So thank you. And any quick questions?
If you have any question,
Just
yes.
the Dombro is a connection on point. That is the concavity and convexity.
You can just think of
That
two inverted black holes. You just simply think of two inverted black holes through a open channel. You think of this is a black hole. Because this is a black hole that we are having, and similar kind of black hole that we are having from the, and suppose we have some connection through this, so that one can pass through this. Okay, then this whole structure we call it the point.
that connects upon one point or only
So
cylinder?
it's a throat.
Cylinder.
Oh yes, it's not exactly cylinder, but you can consider that kind of. So it is a kind of we call it the throat. Bottom पर जमीन पे बड़ा throat है back है like just like this. You even think of. So it provides some kind of path so that one can travel from the upper part to the lower. That is it.
another challenge is throat radius টা কি সেটা আরো ইম্পর্টেন্ট চ্যালেঞ্জ আছে throat radius
how much it can be?
how
Again, that is
calculations is that going from one side
Point knows at the point.
not exactly it is a point. It is a kind of throat. How small it may be, but not exactly a point.
yeah question yeah please.
Sir, actually, I don't have any idea about that, but I am trying to connect this one with the number theory. Actually, so there is a concept, Ramanujan sum, that the sum of infinite numbers is a finite number. That 1 plus 2 plus 3 up to infinity gives us -1/2. So I saw somewhere else that Ramanujan sum is applicable for this Kashmiri as well as the string theory in physics.
Yeah,
Right.
right.
It is unfortunately it is not applicable in the Stephen-Hawking versions of string theory, but it is applicable on the bosonic string theory.
Right.
So how this is applicable, actually, I don't have an idea. So if you have some knowledge about that, so
Okay, for what rules how we can apply this thing? That is your question, right?
Ramanujan sum.
Yes. The thing is that actually we have started with the black hole. Very concept because we don't have any idea about wormholes because already black holes are there and we have a very strong physics regarding black hole. So we have to start from the wormhole from black hole only. Black hole physics. And in black holes, you have already stated that Stephen Hawking has devoted a lot of time, and because of him only, we could now be able to take snapshots of black hole. Because once black hole means you can absorb everything in it. Nobody can escape out of black hole. But that concept has gone because of Stephen Hawking. He has said that is because of the uncertainty relationship and quantum fluctuations, some particles eject out of the black hole. Okay, so this similar concept we can be having here in wormhole also. So we can adopt many things to infinitely many things to reach that particular finite value. Maybe possible, but till today we don't have that much idea because it is directly
That is my actual
applicable.
curiosity,
Yeah.
because an infinite sum gives us a finite number.
I got it because there are some conditions.
So that type of things how you are applying in physics.
Yes, in black hole also that concept is not that. Black hole, that sound is not.
Here also the same problem may come. Yeah, that is good thing, good thing. But in the black hole physics, it is not physics. But wormhole still we are yet to because
So there was a conference in Niger, I think 2017 or 18. Vedant Mahanti,
Vedant Das.
Vedant Mahanti. He's Mahanti.
It's not that's not. It's my friend.
And Professor Vrindavan Sahu. Both were collaborated to that conferences they have organized. That is black hole and number theory combinations. Unfortunately, I was not there.
basically Vedant Das is working not in
Not in this
experimental.
different kind of thing.
Anyway, we can take up the discussion. Anyone, any other question?
Any other question?
Or we'll stop this session.
Students? And students also they should come up. At least this will be open.
Anyway, I mean they can interact with us further also. So with this, we complete this talk.
Thank you, sir. Next talk will be delivered by Professor J.C. Samanta from University of Odisha. I would like to request Professor Steve sir to chair the session. Please, sir.
Next one will be my professor. This is Samantha from Berhampur University. Professor, I invite Professor Samantha to deliver this talk and to finish it in 5 minutes. Okay. So, good morning, good afternoon to all of you. First of all, I would like to express my thanks to the organizer to invite me and to speak something I'm learning from something this week because always I'm very much interested to learn something from anybody whenever I get a chance. So, specifically, my research area is theoretical cosmology. Already few people talked about that, but no, don't worry. I am not going to speak about that. Something different. Something different means it is related to finance. So, let's start with the one statement, not by me, by somebody else. Everybody know perhaps money. Somebody, all big people say always money is not everything, right? But money is required to do everything, right? Yes, of course. So the people who are it's not sorry, no problem. The people those who are telling always money is not everything. Probably that statement is not relevant to the today's society. So now what is my topic is why just I started on finance last 2 years. For that, I was working in theoretical cosmology that already 3 people speak about that. The question is, look, the total universe, this is my concept only, and probably I am wrong, but you try to realize science, technology, and finance. 3 things are very important. Means, if you see very seriously, if you are very good in science, if you do not have any knowledge in technology, then there is no need of science at all. Science, if you see the physics, the base of the universe, then technology. If you do not have any knowledge about technology, I can speak for this microphone, I can use mobile, nothing will be possible. After all, to do everything, you need money. If you do not have good foundation in economy, finance, probably that Chandrayaan 3 will not launch. Okay. So, it's my perception, what I thought, science, technology, money, finance. But behind this, all these things, the one important point is their mathematics. If you see the good physicists, they are very good in mathematics. The good engineer, they are very good in mathematics. Even think about the finance, right? They are very good in mathematics. So, if you are very good in mathematics, probably you can do very good in any area. This is probably the students of the statement of what I said, money is not everything, but still money is required to do everything. And second point, for my students, one question, have you heard about Warren Buffett? How many of you have had Warren Buffett? The students. Okay, few. Okay, right? One in some TV channel asked, he started some investment at the age of 11 years. People ask, how did you start that investment so early at the age of 11 years? He said, I was too late. Means was thinking he could have started before 11 years. That mindset is very important. The question is the what why? Because sometimes if you know everything, but still some extent you should know how to generate, how to create your wealth. If you look, you know A plus B whole square. If you are not able to use that, that doesn't make any sense. That's the very important part. You might have seen 3D picture, right? So always, sometimes we used to say the people, those who are less marks in exam, they are very much successful. But those who are sometimes very good in exam, 99 something like that, but not success, right? So sometimes you have to use the idea. So my topic, today's topic is financial derivatives, options, theory, and its applications. Financial derivatives. It's not the simple derivative. X square derivative is 2x. This is financial derivatives. I will speak. What do you mean by financial derivatives? Derivative word something derives something. Okay. So now this is a whole this okay. I will talk to you. This whole thing develop to what? To create your wealth. Create your wealth means how money makes money. If you have, let's say, X amount, how can generate? Because nowadays in India, probably the inflation rate is around 6%. Means if today you need 20,000 to live, after 20 years, probably that value should be more than 60,000. So now, accordingly, in that proportion, if you are not able to increase your wealth, then you'll be in trouble. If you think about the US, now in India, go to US, ask any undergraduate students, 99% students, they are aware about the finance. Even if you go to any IIT, any NIT, more than 50% students, I think I'm wrong, not more than 50, almost 80% students, they know about the finance. Right? So for that, you need some platform, you should have some awareness. So my topic is financial derivative, options theory, and its application. Okay, for that I'll tell you one more thing. One mathematics professor, Jim Simmons, he was from MIT, no MIT, and then Harvard University. After that, he resigned from the post. He was one of the top 10 investors in the world because the mathematics behind this that I speak. So now, anyway, derivative is the one very big thing in the one segment in the finance. Derivative and option theory. In option theory, I am going to speak about two things: put option and call option. So all these things they develop to protect your wealth. Not for nowadays. Okay. Let me speak one more thing. In India, I think around 3 to 4% people are actively involved in the secondary market. Secondary market means that the stock, right? That is illegal to secondary market. Primary market means look, what is the meaning of this? I started our business. I have initially some lakhs. Then I try to increase that unit. I need more money. Probably I am not able to provide all this fund. Then what happens? If I am able to produce this company into the secondary market, means you have to list in NAC, that is National Stock Exchange, BSE, something like that. There are some guidelines. If you qualify, then what happens? You have to launch through IPO. That is called the initial public offer. Then what happens? The public will invest, put their money in, right? You can use public money to operate your business. So this is a lot of things happen. That is in business category. We don't interest on that. So we should interest on what is the mathematics behind this and how to create some particular model. My question is, so far there is no any mathematical model to start trading or to start investment, something like that. Right? So there are many open questions in this area. So, how to that? Let's say, so, arbitrage, introduction to option clear profile, option moneyness, factors affecting option prices, put probability, option pricing model, application of options. So, arbitrage, what do you mean by arbitrage? Let's say, why India are more interested toward FD? Because in FD, you get, this is usually called the risk-free assets. All of you have some assets in real estate. Bank, that is FD. FD is risk-free. But what is the reward? Reward is probably 6 to 7%. After tax, again 10 to 20% you have to pay. So, moreover, is around 5% to 6%. So, is it possible to beat the inflation? Probably no. Then you have to go for the tech with risk. If there is a risk, there is a reward. But your risk should be calculated. That's the difference in the option. So your risk should be calculated. Now, how risk should be calculated? You must have had some scam 1992. Usually people say Harsha Mehta scam. Do you think it's a scam? I don't know, because he saw some loophole in the system. What is the loophole in the system? That time, now there are many rules and regulations, right, by RBI governor. That time it was not there. What was, let's say, X bank is there, Y bank is there. X bank should pay X amount, some amount to Y bank after 1 month. Now, by that time, that 30 days, that money will be there without use. So, what happened? Asset Metas did, took that money, used for that 30 days in the secondary market, generate huge money there. That was the problem. That was the scam. If you think that is a positive way, it's positive. Otherwise, if you think it's a scam, it's a scam. But the fact is there. Anyway, forget about that. So now, why option is so important? Let's say you have a big portfolio. You understand what is the meaning of portfolio, probably. Because let's say you are going to take some risk, you have to invest your money in some equity, some risk-free asset like FD, ETF, etc. Real estate. Even in real estate, there are many risks. You do not know whether that plot after 5 years or 10 years, whether you are able to sell or not, because so many products are there. So now, when you are going to equity, so you have to choose direct stock or under some fund manager. That is usually called a mutual fund. Direct stock means, let's say, I have one company, you know me, and you trust me, on my company, you can put that money. So how your money will generate? Once my company will grow, your money will automatically generate. That's the criteria. There are so many things. Even dividend is there, money, when company will get more money. So a lot of things that we cannot cover in one lecture. We have only 10-15 minutes. So then you have to take some risk. Either you have to put money in equity, direct equity, or mutual fund. Mutual fund are handled by fund manager. So in direct equity, there is a high risk because probably we are in a busy schedule. We do not have sufficient knowledge about the company, and we are not able to regularly monitor that company. So the better we should go for mutual fund. Now the question is, how much safe? Is it safe? Now, just after COVID-19, 2020, hopefully in India, the percentage of people involved in the secondary market is increased, slightly increased. But before COVID, it was very less. But if you see US, there are more than 62% people are involved in the secondary market. Not only what I said, people. Ask any students, they must have some knowledge about the financial market. So that's what my target was. Students should know at least what is going on. Right? If today I am putting the money into the bank, say 100 rupees, after 1 year, 100 bank giving me 106 rupees, not say paying 6 rupees extra. After 1 year, value of the 100 rupees is equal to 106. You are not getting extra 6 because rate of inflation is going minimum 6%. Now it is more than 6 probably. So then okay, now the question is whether we should go for equity or mutual fund. Better mutual fund. Now the question is, how much risk is there? What is the meaning of the mutual fund? There is a fund manager, he is very expertise on that. He took your money. Because let's say I have very less income. I can save only 1,000 rupees per month. Probably I am not able to purchase one share from Reliance in 1,000 rupees. Then for me, better to go for mutual fund, not for me, even any profession, because we do not have time for that. Right? For that you have to analyze, right? You have to do research, otherwise it's very difficult. I will tell you. So now the question is, once you go for mutual fund, how much it is safe? I would like to say, okay, probably we believe on history. If we believe on history, history says last 10 to 20 years, right? So you may get 20 to 25%. There are so many things, large cap, small cap, mid cap, lot of things that we do not have time to see all these things. So in mutual fund, what happens? The fund manager put your 100 or 1,000 rupees among 50 to 100 companies. They have, and they timely check their status. They do their research whether the company doing well or not. Accordingly, they will change. Then the question is come from arbitrage. Okay, arbitrage is the risk-free investment. What is risk-free? Let's say what happens? Okay, bank providing. Okay, have you think bank when you are going for bank? What is the rate of interest for loan? Minimum PL is 10 point something or 11 point something. Home loan is 9 point something, etc. But when you are deposit FD, how much? That is maximum 7 or 8%. Now think, let's change this. Change this means what? Let's say bank providing me loan is 7% and deposit is 10%. Then everybody will do what? Take loan 10 lakhs. put in deposit, 3% you will get. This is called the arbitrage without any risk. So in secondary market, there is no arbitrage system. If there is an arbitrage system, everybody will do that. So this is the arbitrage. So options, there are put option and call option. Why this is used? This is used, I said, to protect your portfolio. Protect your portfolio means, let's say I have some crore portfolio. Those who are big people, they have hundreds crore something portfolio. And you know, suddenly, let's say market is going to crash. Then how to protect the portfolio? How to protect your profit? That is important. To protect that profit, that financial derivative is there. Means, let me explain about the 10 minutes. Silence. I cannot speak anything. Just because there's a lot of things that there. Okay, let me speak only the option. Call option. What do you mean by call option? Okay, let me explain one more thing. It's a derivative segment. It's a zero sum game. Is that clear? It's a zero sum game. Zero sum game means, let's say 3, 4, n people are playing. I am earning means somebody losing the money. Somebody plus a zero sum game. Money is not generated from the derivative segment. But equity segment, cash and carry segment, money is generated. Because company grow, money will grow. This is zero sum game. So that is true. Now why this zero sum game? Because to protect your wealth. What I said, what do you mean by call option? In an option, there are two parties. One is option buyer and one is option seller. Right? Option buyer and option seller means what? Let's say me and he, right? Let's say we have a plan. I am thinking the particular plot. Think about the plot. I am thinking after 1 month, the plot of the price will be more. Right? Will be increased by some X amount. I am thinking. But to purchase that entire plot, I need a lot of money that I do not have. Okay, if I have sufficient money, then no problem. If I do not have sufficient money, then I should go for the option. Because what I said, I asked the broker, right? Please, I want to buy a call option. That option premium. For that, I need to pay some premium. Then what happens? Once I am buying that call option, somebody will say, then that contract will be by two parties, right? One seller, one buyer. That's what I said, it's a zero sum. One seller, he said, he is thinking that particular plot, maybe after 1 month, the price will go down. That's why, right? He sell me call option. Now the question is, option seller and option buyer. For buyer has a right, but seller has no right. He has obligation. Obligation means, okay, for that there are some expiry date. Let's say we fix after 1 month, right? As for American call option and European call option, two things are different. We are Indian, follow American call option, not follow European call option. European call option is something different. So, what American call option? Once today, let's say I contract sign, me and he sign a contract by end of February. Okay, but now in American call option, on or before we can exercise any time. But European call option, on the date of expiry, you have to exercise. That's the difference between American call option and the European call option. Now question is, how can you fix? I said, let's say option price is 10 rupees. How can you fix that 10 rupees? That's the mathematics. That's the difference of the Black-Scholes models. Have you heard about Black-Scholes model? Probably. Before that, binomial model was there. Lot of things are there. Time is there is no time. Okay, just so what happens? The option price will be determined by what? Black-Scholes models. There is a huge mathematics behind that probability, stochastic calculus. Lot of things are there. Let's say 10 rupees. He sold me. I got. Okay. Now, on or before that price go down, 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 down. Right? Now look. I got call option at 100 rupees. That is usually called the strike price. Right? I have paid the premium 10 rupees. Right? Now, his target was the price will go down. Yes, he is correct. I am wrong. Now I lost how much? 10 rupees.